Welcome to the course Android Reverse Engineering from Scratch, where you will learn Android reverse engineering in 3 hours. So here is an overview of the course. We will start off with the course prerequisites, where we will cover both the skills needed to be able to follow this course, as well as the technical requirements. Now, even though we tried to deliver a hands-on course, we still had to provide a short section with a brief introduction to Android. We will try to keep this as short as possible, but it is good to cover the foundations to understand how Android works, and more importantly, how Android apps work. There are significant differences between Android apps and apps on a more traditional platform like Windows. Here we will briefly cover some of these differences. The rest of the course is more hands-on, and the students are expected to follow and recreate what is being demonstrated. We start off by setting up the lab environment. Here we will go through the installation of all the tools that will be used throughout the course without going into too much detail about their features. We wanted to get this out of the way in order to avoid spending time going through the installation processes mid-exercise. Once the lab is complete, we will go through the process of developing a basic Android app. We understand that there are many students that may not have development knowledge, or else they do have scripting or development knowledge, but perhaps on other platforms and in other languages. The idea here is not to provide a full development course. However, we believe that taking you through the process that a normal app developer or even a malware author goes through when developing their app will provide a better overall understanding of what we need to look for as reverse engineers. After developing a basic app, which will in fact be a malicious app, we will change our hat and go through the analysis of the malicious app through the eyes of a reverse engineer. Here we will use the tools that we installed during the lab setup to analyze the malicious app. Finally, we will take the techniques that we learned during the analysis section and apply them to a real-life ransomware case. Moreover, we will use the analysis results to mitigate the harm caused by the ransomware. Here we will be creating a decryption tool that decrypts the files encrypted by the ransomware. In this section, we will cover both the skills needed as well as the technical specs required to be able to follow this course. As for your setup, you do not require a heavy-duty setup with high specs. But since we will be developing an app and running Android emulators on our machine, there are some things we need to consider. In order to follow the complete course, in an ideal scenario, you would work on a dedicated machine. Virtual machines are extremely popular and will actually work for 90% of the course. In some instances, however, you may encounter issues, particularly when using an Android emulator. If you run an emulator on a VM, it either won't work, or if it will work, it will be extremely slow. If you have no other option but to work on a VM, do not worry. You will still be able to cover most of the course. Just keep in mind, especially when using an emulator, that if something does not work, it is probably due to VM emulator issues. That being said, the parts involving emulators are minimal, and you can always follow the videos to see the tools in action. In our case, we set up a very low-spec machine. Even 4 GB of RAM would suffice. However, in terms of performance, the more the better. Emulators are a bit heavy on storage, so keep that in mind. We are talking a few gigabytes of storage per emulator. In terms of operating system, we will be conducting most of the course across different platforms, namely Linux and Windows. The tools we will work with are either Java or Python based and are therefore multi-platform. We will be conducting the lab setup section on a Kali Linux machine just because it is the least straightforward in terms of installation steps for the tools, so we can show the worst case scenario. In the case of Windows, you will probably be dealing with wizards or single line installation commands. You will notice that in some cases, we'll be switching between Windows and Linux, partly out of convenience, but also to show that the tools work similarly across platforms. Now, as for the skills required by the participants, we designed the course with the assumption that the student is not too familiar with Android. This means that it is an introductory course and we do not require any particular knowledge or skills. We do, however, assume that the student has some basic IT knowledge. For example, if the students are working on a Linux machine, then we are assuming that they would know common Linux commands such as CP for copy and LS for list files. As for the developing a basic Android app section, development knowledge would definitely be a plus, but is not required. However, we do need to emphasize on the point that this section is not a prerequisite for the other sections, meaning that if you are completely unfamiliar with development, we do not expect you to complete the tasks in this section, and not following the tasks would not result in you not being able to work in the following analysis part. We would, however, recommend that you watch the videos with us in order to get a better idea of the process involved in developing Android apps. For any section that you skip, all of the resources will still be available in the remaining sections. We wanted to make this course as hands-on as possible, but we still had to provide a short section with a brief introduction to Android. We will try to keep this as short as possible, but it is good to cover the foundations in order to understand how Android works, and more importantly, how Android apps work. There are significant differences between Android apps and applications on more traditional platforms like Windows. Here, we will briefly cover some of these differences. In this section, we will start off by explaining the Android architecture. Next, we will explain what an Android APK is, before moving into some high-level aspects of Android's security model. Finally, we will explain the App Store concept and go over the requirements when downloading from the Play Store and from third-party stores. Android is an open-source, Linux-based software stack created for a wide array of devices and form factors. The following diagram shows the major components of the Android platform. The foundation of the Android platform is the Linux kernel. For example, the Android Runtime, ART, relies on the Linux kernel for underlying functionalities such as threading and low-level memory management. The Hardware Abstraction Layer, HAL, provides standard interfaces that expose device hardware capabilities to the higher-level Java API framework. For devices running Android version 5.0, API level 21, or higher, each app runs on its own process and with its own instance of the Android Runtime, ART. Prior to Android version 5.0, API level 21, Dalvik was the Android Runtime. If your app runs well on ART, then it should work on Dalvik as well, but the reverse may not be true. Many core Android system components and services, such as ART and HAL, are built from native code that require native libraries written in C and C++. If you are developing an app that requires C or C++ code, you can use the Android NDK to access some of these native platform libraries directly from your native code. The entire feature set of the Android OS is available to you through APIs written in the Java language. These APIs form the building blocks you need to create Android apps. Developers have full access to the same framework APIs that Android system apps use. Android comes with a set of core apps for email, SMS messaging, calendars, internet browsing, contacts, and more. Apps included with the platform have no special status among the apps the user chooses to install. So a third-party app can become the user's default web browser, SMS messenger, or even the default keyboard. Android Package, APK, is the package file format used by the Android operating system for distribution and installation of mobile apps. An APK file is an archive that usually contains the following files and directories: MITA-INF is a directory containing the manifest file, the app's certificate, and the list of resources, and an SHA-1 digest of the corresponding lines in the manifest file. Resources.arsc is a file containing pre-compiled resources, such as binary XML. Classes.dex contains the classes compiled in the DEX file format, which is understandable by the Dalvik virtual machine and by the Android runtime. RES is the directory containing resources not compiled into resources.arsc. Android manifest.xml is an additional Android manifest file describing the name, version, access rights, and referenced library files for the application. You may also have a lib directory containing the platform-dependent compiled code and an assets directory containing application assets. The Android platform takes advantage of the Linux user-based protection to identify and isolate app resources. This isolates apps from each other and protects apps and the system from malicious apps. To do this, Android assigns a unique user ID, UID, to each Android application and runs it in its own process. Android uses the UID to set up a kernel-level application sandbox. The kernel enforces security between apps and the system at the process level through standard Linux facilities, such as user and group IDs that are assigned to apps. By default, apps can't interact with each other and have limited access to the OS. If app A tries to do something malicious, such as read application B's data or dial the phone without permission, it's prevented from doing so because it doesn't have the appropriate default user privileges. The purpose of a permission is to protect the privacy of an Android user. Android apps must request permission to access sensitive user data, such as contacts and SMS, as well as certain system features, such as camera and internet. Depending on the feature, the system might grant the permission automatically or might prompt the user to approve the request. Between application sandboxing and permissions, the OS is ensuring that apps can only perform the sensitive operations that they are explicitly allowed to. If you are interested in knowing more about the Android security model, we recommend this white paper that was recently released by Google. The paper aims to both document the Android security model and discuss its implications. Google Play Protect is Google's built-in malware protection for Android. It automatically scans your device and makes sure you have the latest in mobile security. All Android apps undergo rigorous security testing before appearing in the Google Play Store. Google vets every app and developer in Google Play and suspends those who violate their policies. Play Protect scans billions of apps daily to make sure everything is secure. That way, when you download an app from the official Play Store, you know it's been checked by Google Play Protect. That being said, as we have seen in the past, malware is still able to make its way onto the Play Store. However, when opting to download from the official store or an unregulated third-party store, we always recommend to stick to the official store. That being said, one can also install non-Play Store apps by enabling a simple feature. This practice is called sideloading. When you allow any application to be side-loaded on your phone, you're bypassing the security protocols that are enabled in the Play Store, i.e., what Google does behind the scenes to make sure all the apps you install from the official channels are safe. However, there are reasons, legitimate or not, that cause people to sideload. For example, when apps are blocked for your specific device, when apps are not available in your country, when apps are banned from the official store, in order to download a paid app for free, which may be illegal, in order to obtain an ad-free version of an app, which may also be illegal, for app development testing, and when developing a custom private app. Finally, we would like to discuss an issue that seems to plague the Android OS, and that is the issue of fragmentation. When creating an Android app, you will be asked for the minimum OS version that your app should support. Choosing a newer minimum version will usually mean that your app will be supported by fewer Android devices. The dashboard shows the percentage of Android devices that are running each OS version and lower. For example, here we see that at the time of this report, Android 10 was the latest available release version. However, Android 10 had only 8.2% of the distribution. The bigger the jump in the cumulative distribution, the higher the number of Android devices running that specific version. For example, the difference between Nougat and Marshmallow is 84.9 minus 73.7, which equals 11.2%. This means that at this point, there were 11.2% of Android devices still running Android Nougat. Some of these percentages seem small, but when you consider the billions of Android devices that are out there in the world, 1% of all Android devices is very significant. Imagine you have a vulnerability against one specific version that only has 1% distribution. You cannot simply omit this as an issue, since this vulnerability might still be impacting millions of devices. You may find many of these old versions are not necessarily on smartphones, but rather maybe on televisions or cars, for example. That being said, many of these devices are still connected to the internet. So this is something that's significant and something we have to consider, especially in Android security. You may even come across cases where, for example, a malware author designs malware exploiting a vulnerability for older Android versions and actually checking the version number of the device before triggering the attack. For example, the code would say, is Android version older than Android 5? If so, then launch an attack using some old vulnerability that they found. Now we will start with the first hands-on part of the course. We'll start off by setting up the lab environment. Here we will go through the installation of all the tools that will be used throughout the course, without going into too much detail about their features. We wanted to get this out of the way in order to avoid spending time going through the installation processes mid-exercise. By the end of this section, you should have all the tools needed to conduct the exercises for the remainder of the course. We will be conducting this section on a Kali Linux machine just because it is the least straightforward in terms of installation steps for the tools in order to show the worst case scenario. That being said, if you prefer working on Windows, then you will still be able to follow. The tools we will work with are either Java or Python based and are therefore multi-platform. In the case of Windows, you will probably be dealing with wizards or single-line installation commands. So we will start off with the installation of Android Studio, which is the IDE or Integrated Development Environment used to develop Android apps. Bundled with Android Studio is the SDK Manager and the AVD or Emulator Manager. We will then show the installation path of the Android Debug Bridge or ADB. Then we will move on to the installation of reverse engineering tools, namely APK Tool, JDGUI, and Jarfy, Bytecode Viewer, AndroGuard, and Objection. We will also briefly discuss Tamer, which is a VM that actually comes with all of the above mentioned tools pre-installed. So now we're going to download Android Studio. You just go to developer.android.com/studio or just Google download Android Studio and you'll be redirected to this page. Then, depending on your operating system, you'll be given a download button. Read the terms and conditions, accept the terms and conditions, and click download for your operating system. In the case of Linux, we're going to open with an archive manager. Give it time to download. Okay, once it downloads, we're going to extract the content. Again, this is on Linux. If you're doing the same on Windows, it's much more straightforward. You'll have an installer with a wizard, and that will do everything for you. Also, if you're running on Linux, particularly in a 64-bit environment, make sure you have all the prerequisites installed, as listed on their site. Okay, now we're going to extract the content into, we want to place in user/local. That requires permissions. Let's just put it in the downloads folder for now. And then we'll just move it to the user/local later. Okay, and extract it to your downloads or home location. Extract. Now open your terminal and go to the location where you downloaded it. And we want to move the Android Studio folder to user/local, or wherever you prefer to have your applications. In our case, we're just going to move it to user/local. Make sure to move with sudo. Okay, that's it. Now let's go to the Android Studio folder. So user/local/Android Studio. And within this folder, you're going to have another folder bin. Go into the bin, and you're going to have a script studio.sh. So to run Android Studio, just run // and studio.sh. Once you run studio.sh, you can decide whether or not to send usage statistics to Google. In this case, we're not going to send it, but it's up to you. Then just give it time to open, and it will guide you with a wizard to the next steps. Next up is to install the SDK Manager. The wizard will guide you through the initial setup first. Just choose your UI theme. Next. Review the settings. Make sure JDK location is correct. Don't worry about this too much. You can change it at a later stage. Actually, here it will download the latest SDK version automatically. So it will go to Google servers and see what version is available. Now there's a warning about hardware acceleration. We will discuss this later on when setting up an emulator. Click Next, and it will start downloading components. This will take some time. You're downloading huge files over here. So let's just give it some time. Okay, the process is complete. Once it finishes, just click Finish. So we've installed the prerequisites, including the latest SDK. But let's have a look at the SDK Manager. So there's an SDK for every Android release. In this case, let's download an old version just to show you the process of downloading an older SDK. Okay, so here we're going to go quite a while back. Android 4.1, which is Android SDK version 16. We're doing this because in a later exercise, we'll work with old malware, so just to be safe, we'll run it on an old Android device. So after installing this SDK version, you should have the latest version as well as version 16. You can download as many as you want. Accept all the terms and conditions. You have to accept the terms and conditions for each of the warnings. Actually, before that, let's go to Show Package Details. So if you click on the Show Package Details, it will show you what is being downloaded for the specific version. So let's go to the Android version 4.1 and let's see what we're going to download for this SDK. So we're going to select everything. Here you can see the system image. System image will let us run the Android emulator. We'll see this in the next lesson. Just click and accept all the terms and conditions, or read the terms and conditions and then accept them. Make sure to accept them for all the components. Click Next. And again, give it some time to download. It will take some time since you're downloading large files. So just click Finish. So far we have the latest version, which was downloaded automatically, and now we have an old version, which is extremely old, version 4.1. So we'll be able to run the emulator of both versions. So now we're going to configure the AVD, which is the Android Virtual Device. So to do this, we're going to click on Configure and run AVD Manager. Okay, from AVD Manager, we're going to create a new virtual device. First, we're going to select the template or the hardware profile. So this will configure device-specific configurations. For example, the width and the height, the resolution, aspect ratio, and all the stuff specific to different devices. This is important for Android developers when they want to test their UI on different devices. In this case, let's just choose Pixel X, which is the default one. Here it will show you what system images are available. These will depend on what SDK versions you downloaded. So for example, we have version 29, and earlier we installed version 16. So you see that these are available. The ones that are not available, you will see a download link next to them. We can just click on download, and obviously it will take some time to download, but then you'll have the emulator available to experiment with. Let's create an old emulator. Let's create one of version 16. One thing I like to do is remove the spaces in the AVD name. We do this to ensure that there are no errors caused by spaces when we use a script against a specific emulator. It's not a requirement, but just to be safe. Then you can click on Advanced Options, and here you can choose different properties. So for example, you can increase the RAM. One important thing is that you can configure the emulator performance by choosing hardware or software acceleration. If you choose hardware, it would be much better. It's much faster, but you'll come across many instances where you cannot run hardware acceleration. For example, when running inside a virtual machine. So in that case, you have to do it with software. If you run inside a VM, this means that you're running an emulated system inside a virtual system. This can cause several underlying issues, and many tools will not work because of this. If this is your situation, for certain things we recommend running on your physical machine. When you choose automatic, it goes from hardware and then try software. If you encounter issues when running your emulator, for example, you're prompted a black screen, go ahead and play around with these values and it will probably fix the issue. So just click Finish and you'll have your emulator. If you want to increase your memory, just increase memory. Similarly, you can increase your storage. It's up to you. But the default should run, unless you're running inside a virtual machine, in which case you may encounter some issues. Give it some time to create, and then you'll have the list of AVDs available. Find the AVD you created. If you already created an AVD, you'll have the complete list here. Just click on the play button. Okay, this will launch our emulator. Let's give it time to load. Now, this is a useful utility. Here you have some extra tools that you can play around with. So for example, say you want to emulate sending or receiving an SMS. You can do that using this utility over here. Just click on the three dots on the side, and then for example, you can play with the accelerometer sensors. You can also play with the battery levels. Keep in mind that the emulators are mainly targeted towards Android app developers, not reverse engineers. So these tools are extremely useful for developers. But as a reverse engineer, you might encounter instances where you would need these tools. Say for example, you find malware and you think that it only works in a specific location. Then you can play around with the location data in your app and simulate your device being in that location. This is not uncommon. Imagine the malware is targeting a specific country. Then it is able to get the GPS location and only perform malicious actions when it is in that country. In the case of dynamic analysis, it is very important to be able to expose these actions. In a more advanced course that we're preparing, we'll have a look at this kind of malware that implements this kind of anti-analysis technique, and we'll show you how it is possible to overcome these issues. Okay, back to the emulator. Now, we always need to keep in mind that this is an emulated device. You might encounter some crashes or errors. Perfect system emulation is not easy, so you cannot expect the emulator to work 100% like a normal device. But overall, it's very good for testing, and in our case, it's very good for malware analysis. For example, it is way better to test malware like ransomware on your emulator than on your personal device. So we just set up our first emulator. Now we're going to have a look at the tool called ADB, Android Debug Bridge. So this is a tool that's used to communicate between the host machine that you're working on and the emulator, or even the Android device in the case that you're using an actual device during your analysis. So say you're working on a Linux, Mac, or Windows machine, and you have an emulator running, or you connect your device through USB. Then you can use ADB to communicate between the machine and the Android system. Now, ADB is part of Android SDK. So in the case of Linux, the location of the SDK is usually under your home folder. And inside, you will see Android/SDK. Similarly in Windows, it will be under your user drive, then Android/SDK. Here you will see a list of directories, and inside, you'll see a directory called Platform Tools, and that's where you find ADB. So to run that, you're going to run ADB, and for example, shell. So when you run ADB shell, it's going to take you to the shell of the Android device. So just like that, we're in the environment of the Android device. So within the shell, you can do common Linux commands because, as you know, Android is based on Linux. So for example, you can do ls and it will list all the files. You can change directory, etc. It's very similar to your Linux environment. Okay, and then you can just click exit to go back to your system. You can add ADB to your environment variables since this command will be used by many other tools. We'll go into the details of the ADB and its functionality later on, but here we just wanted to show that you don't really need to install it since it is part of the SDK. Also, it is good to know the location. So far, we've been working with tools that are centered around Android developer and not reverse engineering. But now we're going to download our first security tool. It's a super popular tool, and you can say that it is part of the foundation of most static analysis tools out there. This tool is called APK Tool. So if you just Google APK Tool, you will reach this website. You can install it from github.io, and you can click on Install here. You can see about the different options on how to install it on different operating systems. But on Linux, you can just use apt-get install APK Tool. Now the downside here is that you'll be getting the last version available in this repository, not the actual last version. So now we have APK Tool installed on the system. So let's just run this on a sample APK. Just Google sample APK. It doesn't really matter at this point. You'll be redirected to some popular APK site. Okay, APK Mirror is a popular site that allows you to download APKs. So for example, if there's a specific app you're looking for, say Flappy Birds, just Google, for example, Flappy Birds APK, and it will probably lead you to APK Mirror. As we mentioned in the beginning of this course, it's always better to download from the Play Store. But from the Play Store, you will not be given the APK. So, okay, we downloaded it and we'll just call this test. Let's go to the downloads folder and run APK Tool on the APK using the D parameter. So D for decode. So we're going to decompile the APK. There you go. We will have a look at this tool in more detail during the reverse engineering part of the course. So another tool we're going to be looking at for static analysis is JDGUI. So if you Google JDGUI, you'll be redirected to this site. This is a Java decompiler. JDGUI stands for Java Decompiler Graphical User Interface. So what we want to do is just download this jar file over here. Depending on your operating system, choose the correct download. So save the file. So now we have JDGUI installed over here. So let's run this using java-jar JDGUI. And this is what JDGUI looks like, okay? So here we'd have to import a jar file. Now, in order to be able to use JDGUI with an APK, you will have to download another tool. You are not able to import an APK to JDGUI out of the box. So there is this tool called Njarfy that is able to convert our APK to a jar file. So let's just search Njarfy. Okay, download Njarfy, the entire project. Open with Archive Manager. You can move it to another location if you prefer. So for example, let's move it to /user/local. In this case, it is already present. So now once you go to user/local/Njarfy, here you're going to see the Njarfy script that we will run against a specific APK. So ./Njarfy myapk.apk. We will see the entire process of using Njarfy with JDGUI during the last section of the course. But next we'll introduce a similar tool that is even better than JDGUI, Bytecode Viewer. So we just saw APK tool and JDGUI. Now we're going to see another very useful tool, Bytecode Viewer. This tool actually makes use of both APK tool and JDGUI in the background. So just Google Bytecode Viewer, go to their site, and download Bytecode Viewer here. Let's just download the latest version. Save file. You can run this tool on several platforms. So with Bytecode Viewer, you upload an APK, and after some processing, it presents the APK's decompiled Java source, as well as the bytecode and Smalley, all in a single user interface. So you can have a comparison of the Smalley versus the Java, or rather the decompiled Java. Instead of running APK tool, Njarfy, JDGUI, etc., you can just use this single tool, which pretty much automates the process while offering a nice UI, along with some additional utilities. So let's go to the folder where we downloaded it, run java-jar bytecode viewer, and this will launch Bytecode Viewer. We won't go into too much detail right now, but let's just see if we can add an APK. So let's try the test APK we installed earlier. So there you go. We just uploaded an APK without having the source code of the application and using some Java decompilers. In this case, Fernflower. We have the almost Java source. Now there are different Java decompilers bundled with Bytecode Viewer, so you can choose which one to use. We'll have a look at this later on during the analysis part of the course, but this tool is a great tool for static analysis. Another static analysis tool we're going to work with is called AndroGuard. It is a static analysis tool that is a collection of Python scripts on top of the basic static analysis tools, including the ones we saw earlier. For example, it uses APK tool in the background, and runs Python scripts on top of that to provide some automated, useful information about an APK to the user. So installation on Linux is super easy. You can run apt install AndroGuard, and that's it. After some time, you see AndroGuard downloaded. We will see this in action during the analysis section. So next we're going to install Objection. This tool will be used for dynamic analysis. So just Google Objection Android, and the first result you find is Objection. Okay, some basic information. It's a runtime mobile exploration toolkit. It's an extremely useful tool. But if you go to the installation page, have a look at the prerequisites. So for example, Python. You have to have Python version 3.4 or greater. pip3 has to be version 9.0 or greater. So make sure you have these installed. Another thing, you should make sure you have zip-align installed. Otherwise, you might receive some errors during installation. So let's just run sudo apt install zip-align. Here it is already installed. Now, Objection uses apktool in the background. If you remember before, we installed apktool using apt-get. Let's actually remove apktool and install the latest version. So sudo apt-get remove apktool. The one we installed was actually an older version, and you may receive errors when running Objection. Anyway, this is a good exercise to show you how to upgrade apktool if needed. So just Google apktool installation, go to their page. There are different versions for Windows, Linux, and Mac OS. Follow their instructions. So first step is to download the script. Save this as apktool, then download the apktool.jar. Just find the latest version from here. One thing we need to do is rename that. So we just name it apktool without any version number. Okay, saved. Give it some time to download. Okay, so now we have apktool downloaded. We need to make them executable. chmod plus x apktool. chmod plus x apktool.jar. Now just move these files to user/local/bin. Let's just go to user local bin. We will see our apktool files. So that's where we can run our apktool from. Now you can add this to your environment variables. Okay, apktool is installed. Another tool you will need is jar signer. So make sure you have JDK installed in your system. And also make sure that there's an environment variable pointing towards it. In our case, it's downloaded in user/local. And if we go in this folder, we can see jar signer is available. To see if you have jar signer, just type jar signer. Okay, now with all these tools installed, you should be able to install and run Objection. We thought we would show you a few prerequisites that can cause errors if they are not properly configured. And finally, you can install by using pip3 install-u Objection. It is important to have all the environment variables set. Make sure to have the following tools configured in your system, with the path directories configured according to your application paths. Okay, so in this section, we showed you how to install a number of Android analysis tools. But there is also the option of downloading a VM that comes pre-installed with most of the tools we mentioned. So a popular one, for example, is Tamer. It is a virtualized platform for Android security professionals. So basically, it is a virtual machine with all the required tools pre-installed. Here we have an instance running. So if you click on the menu, you have the manual analysis section. reverse engineering section, dynamic analysis, forensics. So rather than installing all the tools one by one, you can just use a virtual machine like Tamer, or some other one like Santoku, which is very similar to Tamer, just a bit older. The catch here is that, as I mentioned earlier, with emulators you could face a few problems when running inside a virtual machine. But if you're just going to do static analysis or basic analysis, then yes, maybe just install Tamer or some other operating system to do the work. Alternatively, you can try and install the OS on a bare metal machine, then you would be able to use the emulator. You can also install Tamer and see what tools are being used there. Then try and install the same tool on your own analysis environment. A number of tools we worked with assume the presence of certain paths configured in the environment variable. In our case, we had the following variables configured. Make sure that you have the following tools configured in your path environment variable, depending on your own OS and installation paths. In this section, we went through the installation of all the tools that will be used throughout the course. We did not go into too much detail about their features, but we will do this in the upcoming sections. Now you should have all the tools needed to conduct the exercises in the remainder of the course. Now that the lab is set up, we will go through the process of developing a basic Android app. Here we will only be using Android Studio and an Android emulator. Feel free to create a new emulator before moving on to the rest of the course. Maybe you would prefer to see the app being run on a more recent emulator. We understand that there are many students that may not have development knowledge, or else they have scripting or development knowledge, but perhaps on other platforms and in other languages. The idea here is not to provide a full development course. However, we believe that taking you through the process that a normal app developer or even a malware author goes through when developing their app will provide a better overall understanding of what we need to look for as reverse engineers. We will start off by developing a simple shopping list application. We will then code some malicious operations, namely the theft of SMSs and contacts that will run in the background. The idea here is to create an app that uses all of the Android components. Android apps have four main components: activities, services, broadcast receivers, and content providers. An Android activity is one screen of the Android app's user interface. In that way, an Android activity is very similar to Windows in a desktop application. A service in Android is a background process. Services are typically used for processes that are ongoing or that take a significant period of time. A service doesn't have a user interface, so they are often combined with other components such as activities. The Android system makes various types of broadcasts an app can respond to. To receive broadcast announcements on Android, your apps can use a broadcast receiver. A content provider is a component for managing a dataset. This dataset can be private to your application or can be shared with other apps able to query and modify the data. The app will also make use of a number of permissions. We will start off by going over the application structure. We will then proceed to demonstrating the UI components of an app. Then we'll be adding features to the app by using the four main Android components. Let's start by opening Android Studio and start a new project. Select all the default settings and a plain app with an activity. Let's give it some time to start. So once we generate a new project, we will see some processes running in the background. These are related to Gradle. Gradle is the build system on Android Studio. You have all the build properties in your Gradle properties file. Here you can include libraries from repositories, and once you update the code, the project will start building these Gradle scripts and download whatever is included in them. If it's the first time you're ever doing this, it might take a while. So let's just have a quick look at what is included in the application. So this is just an out-of-the-box Hello World application, right? We can see over here is the main activity, which is created by default. Let's have a look inside. Next, we have the layout of an application. In our activity, we point to a layout, which is where we have the user interface. Another important file is the Android manifest. Think of it as a file that explains the main features of an app to the Android operating system. Here we will define all app components and permissions that an app uses. Android wants to know in advance what the components in an application are. So it goes to the Android manifest file, and all the components will be defined within the manifest. There are different types of components. The idea of this section is to develop an app that makes use of all of these components. Another important thing defined in the manifest is the permissions. So for example, say we want to make an application that can send SMSs. Okay, you can write the code inside your activity. So say you go to your activity and write telephony manager.send SMS or something along those lines. This will not work unless we define the permission over here in the manifest, saying this app can send SMSs. We'll show you how to do that later on in the course. Okay, so we have the activity, the layout, and the manifest. We also have the resources directory. Any resources that are to be included in the app, be it XML files, strings, or images, these should be placed in the resources directory. So for example, under resources and values, we have a file called strings, and this is where we would put all the strings that we refer to in the application. So for example, say there's an app title that we want to refer to in different places in the application. We'll define a string, call it my title. And then we can just refer to it across the application by using string/mytitle. This is just used to keep everything consistent throughout the application. Similarly, we have styles over here. So say for example, in your app, you don't want to show the taskbar or the action bar at the top. Then you can remove it from the style, and every layout referring to this style will make use of it. So what else? Okay, so the layout of the user interface that's associated with an activity. So here we see that by default, it creates an activity called main activity, and the main activity sets the content to the activity_main layout. And if we go on activity main layout, we'll see that this is the user interface that's created by default. We'll be looking at these user interfaces later on in the course. Drawables, here we can put any images. So for example, by default, you get the Android logo as an image. So if, for example, you have your own logo, you upload it over here and change the reference, then all logos will be changed to yours. So that's our default application out of the box. Okay, so at this point, we have a plain Hello World app. So say we want to run this app, all we need to do is click on play here. Here you will see all the emulators that are available. If you click on run, you will see the app running on the emulator. Let's give it some time to run. Okay, so here you can see the Hello World app that was created out of the box. So next we're going to look at UI elements. UI is not always important for reverse engineering. However, there is the aspect of event handlers that might be of interest to us. So for example, when you click on a button, what is actually happening in the code? Within the code, is there any reference to, say, an edit text within the user interface? So for this, we're going to create a simple button and an edit text and attach some code to them. Okay, so in the resources, layout, main activity, we can see the layout that is associated with the main activity. Actually, if we go to our main activity, we can see the layout we are referring to. Now in the layout, we have two views, the design view, which is drag and drop. Then we have the text view, which is the XML version of that UI. In the XML, you can, for example, add a text view by copying and pasting the existing one. For example, if we add more characters to the copied one, we see that there are two text views behind each other. We do not need to go too deep into this, but let's just add a button and an edit text for now. So first of all, in the view, you can set it to only see the blueprint. Then you can zoom in and out by scrolling in and out with Control pressed, or just by clicking on the zoom buttons. Okay, let's drop in edit text and a button. If we would have to run this as it is, you will see a few inconsistencies. So let's run. Here you can see they are on top of each other. This is because we need to configure the constraints. Again, this is not too important, but let's just make a simple constraint. So first thing, we're going to add a top and side constraint for the edit text. Right now there is a 0 default margin. Let's change this to 16. Next, we're going to tell the button to relate its position based on the edit text position. To do this, we're going to right-click on the button and do Show Baseline. Click on the button and link the baselines. Also, from the left side, we're going to create a left constraint linking the button to the edit text. Now, if we run the app again, you'll see the edit text on the left with the button on its side. Okay, so now that we have our user interface ready, we're going to edit some properties attached to the user interface. So let's say, for example, you click on the button. Over here on the right, you have the attributes that you can modify. Let's change the ID, for example. Let's call this button send. Okay. And let's call this edit text. List item. Okay. And just like that, we've updated the IDs. Now, what about the text? So let's see the button. Let's say we want to edit the text on the button. We want to make it say send. We can edit it from here. And then you see it changes to send. Now, another thing we could, if you remember under values and strings, we have a list of strings. What we can do is create a new string. Call it button text. Set the value to send and change the reference in the button. So rather than just putting the text directly, we used string. It's just a bit cleaner like this. We're seeing both approaches since developers tend to use both string and direct text. And then with edit text, usually what you'd find is something like help text rather than text. So let's say we click on the edit text. Let's remove the text. And you can put hint. A hint will be, for example, enter list item here. Okay, so now what happens when we run it again? So you click on the rerun. This just reinstalls the application on the device. And here you can see now we have the text send and enter list item hint. Okay, so it's straightforward enough and not too complicated. Again, for reverse engineering, it's not as important, but you might come across cases where you need to understand what the malware is doing in terms of the user interface. Next, we'll be attaching code to these UI elements. We'll see how the code interacts with the user interface. Before we continue, I'd like to point out that you may have noticed that we're currently working on a Windows environment, whereas before we were working on a Linux environment. We're simply doing this because the Windows machine is faster than the lab Linux machine. It's just a matter of convenience. But the entire section is exactly the same. The only difference is the file system. So for example, here the project is saved in D drive. In Linux, it will be under your home directory, but that is it. Whatever we're doing here in Windows, it will work exactly the same in Linux. If you have any issues in this regard, just let us know and we can help you out. But you shouldn't face any issues. Just follow everything we're doing. Okay, so right now we have 3 UI elements. Here's the hello world that is included by default. And here we added a send button and an edit list. So what we're going to do now is interact with the UI elements. We're going to add text in the edit text. And when you click the send button, the text that's added to the edit box is going to appear on the text view over here. So to do this, we have to go on the activity that's linked to this user interface. Now there are 2 ways of creating event handlers. We're going to show you both ways. First, let's see the more common way. We start by going to the main activity. Now this is going to involve some programming. If you don't have programming experience, don't worry, we'll provide all the code. It's just a matter of copying and pasting. We'll also provide the entire project that you can just import and follow what we're doing. If you prefer, just follow what we're doing and try to understand which code goes where. To be a reverse engineer, you don't have to be a developer. Okay, so here we're going to create an event handler. So we're going to create what's called a method. The method is going to be called public void, and we're going to call it post item. Here we are going to write view. Okay, don't worry too much about that red warning. We'll go over those soon. First, we're going to refer to the edit text that we have in our user interface. To do this, we're going to use the class edit text, and we're going to define a variable and call it ET. This is not a programming course, so we're not going to go into too much detail about these details. We mainly want to give the reverse engineer an idea of the process that the malware author goes through when developing an app. So here what we have to do is find view by ID, r, id dot edit text. So what we just did here was create a variable called ET, edit text, and we're telling it this edit text is going to be the UI element with the following ID. So here we're linking the code to the user interface element. Similarly, we're going to do the text view. Text view, TV equals find view by ID. Actually, we need to add an ID to the text view. So let's call it text view. Okay. So we go back to our find view and pass r.id.text view. So now we've added a reference to our edit text and a reference to our text view. What we're going to do is simple. We're just going to say tv.setText et.getText. What does this mean? So we're referring to the TV text view, and we're telling it to send the text of the edit text to the content of the text view. Okay, so it's quite straightforward. We're just creating an event handler that's getting the text from the edit text and posting it into the text view. That's literally what we just said over here. So here we see that there's an error, so it won't compile. You're seeing there's that red line under here. Now, Android Studio has this autocomplete function where it tells you when there's an error and how to fix it. So in this case, here it's telling you that we were missing a class reference. We're missing the following imports. So here it's actually telling you what you need to do. Do you need to add android.view class? If so, press Alt and Enter. When you press Alt and Enter, you see that it automatically added this import in this class, and then the errors are gone. Okay, so if we run this now, you'll see that nothing happens. So why is this? We run the application. You have your user interface, and you click it, but nothing happens. The reason is that we need to attach this event handler to the button, and this hasn't been done yet. So to do this, we're going to use the user interface, click on the button, and there should be on click over here, on click, and you're going to choose, it automatically detects what event handlers are available for you. Just click on that, and now it's been attached. So what happens now when we run the application, there you go, it worked. So if we write test and click, you see that test gets written in the text view. Okay, that's your first simple user interface application. Next, we'll show you how to do an event handler in another way. So let's go ahead and remove this event handler. And we just detach the event handler on click from the button. So now we're back in a situation where if we click on the button in the application, nothing happens. Now, another way of creating an event handler is by doing everything in code. This is useful when creating UI elements and event handlers dynamically. So we won't refer to the event handler within the XML, but rather we'll just create it in Java programmatically. So in this case, for example, we can go on the onCreate method. So the onCreate is what happens when the activity starts. So when the activity is created for the first time, this code is executed. And you'd be able to attach your own actions over here to run after the first execution. So in this case, what we're going to do is we're going to say button btn equals button find view by ID r.id.button send. So what we're going to do here is we're going to put an event handler directly on the button. So to do this, we're going to say btn.set onClick listener. So here I'm going to show you how developers work. Google Stack Overflow button onClick. And usually in the first post, you will find your reply. Copy and paste and change your IDs. This is how many developers actually work. There's no need to remember all of the details, Stack Overflow usually has the answer. Then in the onClick function, we just copy the same code as earlier. Fix it up a bit. What we have here is we created a button. Define an event handler, telling it onClick, add the text from the edit text to the text view. Now we have to run this. Enter text and click. And as you can see, we get the same behavior without specifying anything on the user interface. We did everything programmatically. So in both scenarios, you get the exact same behavior. It's just a matter of preference for whichever option you choose. So far, we've been working with activities, and we've seen how to interact with the user interface within the activity. What we're going to show you now is how to switch from one activity to another. But before we do that, let's have a look at the life cycle of an activity. So before we saw the onCreate, if you remember, when we saw this part over here of our activity, we were working within the onCreate to create the event handler. But there are a few other events in the life cycle of an activity. So there's, for example, the onCreate, then there's onStart, onResume, onPause, onStop, onDestroy. So they're all quite self-explanatory. I mean, you have onCreate when the application is created, onStart is every time the app is started, onResume, say for example when the app was already started and you minimize the screen, then you go back to the interface of the screen, then in that case it starts the onResume. Then there's onPause, which is what happens when we minimize the application but it still runs in the background. OnStop is when you exit the application. And onDestroy is the final call you receive before your activity is destroyed. This can happen either because the activity is finishing, for example, when someone called finish on it, or because the system is temporarily destroying this instance of the activity to save space. It's quite important to know the sequence of these events. It's more important for a developer than for a reverse engineer, but it's always good to know these. Okay, so now what we're going to do is we're going to create a new activity. So let's say a new Java class, type class, name, call it, let's say, display, list items. Let's leave it as it is right now, and then we'll fix it in the class. So now it's going to be an app compat activity. So we're going to tell it to extend app compat activity, and it automatically imports the libraries and required methods. Use Alt-Enter where needed. So this is an activity, so we need to have an onCreate. Add the onCreate. Okay. And like this, you're working with the onCreate method in the app compat activity. So you're telling it what to do when the app is created. So now before we do anything over here, we're going to add a new layout. Let's say add a new layout, resource files. Let's call this list items. Okay. Let's leave the default settings right now. So now we're going to go back to our display list items activity, and here we're going to tell it to set the content view r.layout. And we're going to tell it which layout to display. Right now, this doesn't do anything. It just created a new activity and a new layout. So one thing we need to do is define the set of activities in the manifest. So in order to do this, we're going to go within the application tag. Within the application, we already have our main activity, and now we're going to copy another activity. We can just copy and paste the same one and rename it. Remove the extra info, which is for the default activity. Okay. So yeah, that's pretty much it. Let's see it's working. At the moment, we're not doing anything with the new activity, but now we'll add some code so we can interact between the activities. So now that we've created another activity, let's see how we go from our original main activity into the display list items activity. And also, how can we pass data to this activity? Let's keep working with this event handler over here. So if you remember earlier, we attached the event handler on click. So let's comment the content out. To comment out, all you need to do is select the lines that you are working with. Press Ctrl and /, and this will automatically comment out the lines that you're working with. Let's start with writing code over here. So first, jump to the new activity where you're going to use an intent. Intent. I equals new intent. Don't worry about the red warnings for now. Pass the context and the class of the intent to jump to. Press Alt and Enter everywhere to fix the errors. Then we're going to get the text from the edit text, like we did earlier. So let's do that. Define a string list item and call this et.getText. Convert this to string. Now we have our list item. Next, we're going to pass the string to the new activity by using putExtra. To do this, we define a variable with the ID of the item to pass. We define it as public in order to access it from the other class. Then we just put the value. So putExtra uses a sort of key-value pair. You pass the key, then the value. Once this is done, we just start the activity by running start activity. Okay, now let's set up what happens when the new activity is opened. First thing is to obtain the string that was passed by the original activity. To do this, define a variable called intent and set it to getIntent. Next, we define a string, call it item value. Then we get the string by writing intent.get string extra and pass the ID by pointing to main activity.extra item, which is what we defined earlier. Okay, now let's go to the UI and let's drop a text view. Change the ID to text view list item. Now in the activity, we can refer to the text view like we did in the previous section. So text view, TV equals find view by ID, r.id.text view list item. Then we will change the text of the text view by writing tv.setText and pass the item value we obtained earlier. Okay, so let's run this. Now if we enter text, click the button, and as you can see, we have a new activity opened, and the content from the edit text was passed on to the new activity. Another thing we can do is add a back button in order to have the activity go to the previous activity. To do this, we edit the manifest and add Android : parent activity name equals dot main activity. And in the metadata, we need to add Android : name equals Android dot support dot parent underscore activity and Android : value equals dot main activity. Now when we run it again, add text, click the button, and here you can see we have a back button in the activity, which sends us back to the original activity. So we've seen how to work with activities and how activities can interact between each other. Now we're going to look at content providers. Earlier we mentioned how apps run in sandboxed environments. A content provider allows an app to expose data to third-party apps. So taking the example we're working with, say we are working with a shopping list, and we want our app to be able to use this data, but also share it with other apps that may want to access our shopping list. So what we want to do now, let's change the UI text of the button and call it Add Item. Now what we want is, when we click on Add Item, we want to add the text to a list. Now the code behind this is a bit complex and out of scope, so we will be providing a lot of code that you will copy and paste. But we'll just show you some of the steps involved in order for you to know what to look for in content providers. So the code itself, if you're familiar with SQL, you will immediately see the similarities. So we created a database helper. We just do the basic stuff of creating a database, inserting a row, querying the database, deleting an item, updating an item, standard SQL stuff. We will not go into the details of implementation, but have a look at the code to see the format. Okay, so at the top, we're defining a provider name. This is important since we'll be referring to it. Same thing with the URL, which contains the provider name. And this will be referred to within the code in the activities. Okay, now we're going to modify what happens when we click on the button. Before we were taking the text and passing it on. Let's remove this or comment it out. Instead, now we are going to say when the button is clicked, we're not going to pass the text as a parameter to the other activity, but instead we will add to the content provider. So to do this, we still want to get the initial part of defining the activity and getting the edit text. The different part, however, is if list item is not equal to null, then content values equal new content values. Values.put list provider dot list item and add list item. Now define a URI of type URI and call getContentResolver. Insert and tell it what URI we're passing to and pass the values. Okay, and just like that, we added to the content provider. And same as before, we want to start the activity. Okay, now in the display list items activity, instead of receiving the value from the previous activity, we want to obtain the list items from the content provider. Think of it as a database that we want to query. So let's create a method called private string getListItems. Inside, we are going to say string URL equals and the name of our URL that we provided earlier. Then URI list items equal URI dot parse URL. Now to parse each item, we use a cursor. Cursor C equals get content resolver dot query and pass list items null, 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 and order by list item. So this is similar to SQL here, where we tell it what to sort by. The other nulls are parameters that are out of scope. Okay, now define a new string called results. Declare as an empty string. And for each of these, we will say if c.move to first do results equals, just copy this entire text. Here we are putting a query. Don't worry too much about the actual syntax. Just know that we're pointing to the items in our content provider. Okay, then we return to results. So what are we doing in getListItems? We are just pointing to our content provider, listing all items and adding them to a string. Then we return the string. Okay, now in our onCreate, instead of passing the item we just received from the previous activity, we want to get the list items. This will also include the item that was just added to the list before opening this activity. Okay, now an important thing before running this code. If you remember, we said that all the Android components have to be listed in the manifest. We also need to define this content provider in the manifest. So we just define a provider, Android : authorities equals com.flipcortex.helloworld.listProvider. Android : name equals list provider. Close the provider, and that is pretty much it. Okay, now we run. Add item to list like milk. Add item, go back, add cheese, and as you can see, we are adding items to the shopping list. Again, the idea here is just to demonstrate a use case of content providers. We don't need to know the exact syntax of everything, but it is important to know what a content provider is and what it might be doing. If you did not manage to follow, don't worry. We'll be providing the finalized versions you can work with in the following parts. So now we have a simple shopping list app. Obviously, it's not market ready, but we just wanted to show a simple app that uses some of the main features in an app. Now let's imagine that the person creating this app has a malicious intent. Say, for example, they want to intercept incoming SMSs and send them to their server. So to do this, we need to create a broadcast receiver. Think of a broadcast receiver as a service running in the background that listens to system-wide events, such as an SMS being received and the phone booting up. So any app that wants to trigger an event upon seeing that a system-wide event occurred has to implement a broadcast receiver. Let's create a new class called SMS Receiver. Leave the default config for now. Okay, this is a plain class. Let's make it extend broadcast receivers. This will give errors. So Alt and Enter to fix the errors. And you see that it creates a new method called onReceive. So for now, this is a generic broadcast receiver. The first thing we need to do is determine what system-wide event just occurred. And we want to determine if it is SMS received. So to do this, define a string called SMS received and set it to android.provider.telephony.sms_received. Now, first thing we're going to do is say if intent.getAction.equals SMS received. And then we want to do something. Okay, so here we see that we have an onReceive event. This could be SMS received, but it could also be other events. So we are asking the system, okay, what is the event that just occurred? Is it SMS received? Yes. Then, okay, let's do this on the SMS received. Now again, remember that as a developer, you would just Google Android receive SMS programmatically. First answer is usually Stack Overflow. Usually someone is asking a question, then someone provides a correct answer. Find an example that looks right, and copy and paste the content. And fix the issues. Now let's toast the message. Toast means to alert the user. So show text in a pop-up window. Okay, so toast.make text context, the string to pass. Let's copy this from the log. Give the length of the toast, so how long to keep the message prompted. Then show. Now this is not going to work out of the box. This is for two reasons. One, we need to define this broadcast in our manifest, since this is an Android component. And two, we need to add the permission of SMS receive to the app. Now to add a receiver, just add receiver and Android name. Then add an intent filter and say action. Android:name equals android.provider.telephony.sms_received. Then we define the permission on top of the application. Just add uses permissions and find receive SMS. Then close the permission. Okay, so without these, the SMS receiving functionality will not work. Now, as reverse engineers, this is great for us. Say we have the suspicion that an app is stealing received SMSs. The first thing we need to do is go to the manifest and see if there is such a broadcast and if there is the SMS permission. If this is the case, then we know that indeed the app is receiving SMSs. Then we would look into the defined broadcast receiver to see what the app is actually doing with the SMSs. We will be doing exactly this in the next section. Okay, so before we run, since Android version 6, a new step was added when requesting dangerous permissions. So inside our main activity, we need to create a method that prompts the user to explicitly allow the permission at runtime. So the first time the user runs the app, they will be prompted to confirm that the app can receive SMSs. So to do this, we will create a method called request permission. I'll just copy the text here. Again, this is a very common operation, so just Google how to request permission programmatically. Here you'll see that we're checking for the app version. Then we are checking if the permissions are already granted. and if not, we are requesting the permissions. Okay, so let's run the app. Here we will be prompted to allow SMS receive. Now here, there is this utility that allows us to emulate a number of operations, such as the receipt of an SMS. So here we are emulating the receipt of an SMS. So go to Phone, add the number, add the text, and click Send Message. And you will see the SMS being prompted. Obviously, the malicious code will not want to prompt to the user, but rather send to a malicious server. And this is what we will do in the next lesson. Now let's say we want to use an HTTP post to send the SMS received to a malicious server. Now let's comment out the toast message. We do not want to show the user that we are accessing the SMS, but we want to copy the contents of the SMS. So just copy this and create a string with the content. Now, there are many ways of doing an HTTP post. Here, we just prepared some code, so just copy and paste from the resources. We have a method called HTTP post that receives a string. It prepares an HTTP post to send to this particular site called postman-echo.com. And as a parameter string, it adds SMS text and appends the string we passed to HTTP post. That's pretty much it. Now to run this, we need to run an asynchronous task. This means that when it's invoked, a separate thread is launched and the rest of the process can keep going. This is not too important. Again, this is something specific to programming, but with the way we implemented the HTTP post, we need to run an asynchronous task. What is important to us is that we have an SMS being received, and this SMS is being sent over HTTP post. Okay, now to launch the asynchronous task, we need to surround it with a try and catch. This here is a common convention that tries to run code, and if there is an error, rather than crashing, it runs the code in the catch part. This is referred to as error handling. Okay, so now we'll execute the asynchronous task like so. All of this code will be provided for you. Don't worry too much about it. But just by looking at a number of strings here, we can get an idea of what's going on. We have an SMS, we have an HTTP post straight after. That on its own can't be very good for the user. Now, this will not work as is. The reason is that here we're using the internet. And the use of internet requires the internet permission. So here we need to go to the manifest. And here we need to add the internet permission. This permission does not need to be explicitly requested to the user. Google decided that it's not dangerous enough to need to ask the user for consent, or it is so common that users kind of expect the apps to use internet permission. So let's run the app. Send a test SMS. We'll not see anything in the app, but what happened is that the shopping list app just stole the SMS and sent it to their server. This is actually something we will analyze during the dynamic analysis part of the course. So far we've seen an activity, a content provider, and a broadcast receiver. Now we're going to look at a service. So here you're probably familiar with services from other operating systems. The concept is similar here. You usually use a service when you want to do a long task in the background, or you want to expose features of your app in the background. We won't go into too much detail here, but we will show a basic service and how to define it. So let's add a class called MyService. Default settings, extend service. Alt and Enter to implement methods. And here you can see it created the onBind method. So just as the other components, we need to add this service to the components in the manifest. So service, Android:name equals MyService. Let's give it an icon. Android:icon equals drawable IC launcher background and a label. Android:label equals string app name. Okay, so we just defined a service. Now, if you remember, we had the life cycle of an activity. A service has a different life cycle. Actually, there are two options depending on how they were launched. So here, for example, you have when it started with the onStart command, and here with onBind. Then there is the service running, the unbind in the case of bind, and onDestroy over here for both. So just like that, we have our service defined in our app, but it doesn't do anything yet. So now we have a service. As a malicious use case, let's say every hour we want to steal the user's contacts and send to the server. There are better ways of doing this, like using alarm service, but here we just want an excuse to use a service. Now let's start off by providing the permission to read contacts. So go to the manifest and add read contacts. Now, besides adding to the manifest, we need to prompt the user to allow read contacts. Let's just update the method we wrote before to add the new permission. So go to main activity, go to request permissions, and change it like so. Okay, so here just copy and paste the code. So now instead of checking one permission, we're checking two permissions. Now, similarly, we prepared HTTP post code for this. This is quite dirty. In reality, you would have a separate HTTP class and so on, but here we're just copying and pasting, doing the bare minimum. Okay, now to obtain the contacts. Similarly, if you go to Google, search Android read contacts programmatically. You'll find a Stack Overflow article with the solution containing the code. Here, we prepared it earlier and just copy and pasted the info. So we have a method that gets all the contacts and returns a string with all the contacts. So if you look at the code, they're just getting all the contacts. It actually does this using a cursor just like in our content provider, and we return a string with all the contacts. In the HTTP post, we change the parameter name to contacts. Okay, next we're going to use a handler to define the action to perform periodically. So handler, mHandler equals new handler. Let's define an interval integer of 1000, that is milliseconds, times 60, that is seconds, times 60, that is minutes. So since the system counts time in milliseconds, we're saying we want the interval to be that many milliseconds, which means 1 hour. Now we define a runnable and create the run method. Surround with try and catch for error handling. And here we will invoke the network asynchronous task like we did earlier. But as a parameter, we will add the contacts instead. Okay, and after it runs, we will tell the handler to delay the next action by an hour, meaning this will run again in 1 hour. Similarly, to do this, a developer would usually search on Google how to run a task every hour. And you just take the code from the forums. Okay, now to execute, we need to tell it when to start this event for the first time. Let's put this code in the onStart. So just copy the onStart method. We need to override the original onStart command and put our code inside the onStart. So we are saying that the first time we run the service, we're going to call the handler. So let's define a method for our handler. Let's call this one start recurring task and the other one stop recurring task. Then inside we say mHandlerTask.run. And here, mHandler.remove callbacks, parentheses, mHandlerTask. So here we are just stopping it. Now, if all of this is overwhelming, really don't give up. This is not needed for reverse engineering. We're just showing you the process that a malware author would go through when writing code. You'll get used to these terms in classes more and more as you go along. In programming, there's always a lot of repetition. Okay, now in the onStart command, we will call start recurring task. So here we just said that once we start this service, every hour it will send the contacts to the server. Now we still have a final step. We need to start the service from within our activity. So go back to our activity, and in the onCreate, just start a new intent to start my service. Then run start service and pass the intent. Okay, now we run our app. You'll not see anything different other than being asked to allow a new permission, being contacts. Actually, we need to add a contact if you don't have any contacts. So just go to contacts like you would on a normal Android device and add a contact. Now finally, let's see an interesting feature in Android Studio. So for debugging, we can add breakpoints. This means that you tell your app to stop at that point when it reaches that code. And you can analyze everything in code at that specific point. Okay, so to do this, we just click here to add the breakpoint. Let's add it in the HTTP post. Then we run using debug. And when it reaches that point, we can see that Android Studio shows us the point has been reached. And we can also monitor the values. So the contacts are there. Now here we're able to debug easily because we are actually developing from source. Unfortunately, debugging in APK is not as straightforward. But this is something we will have a look at in a more advanced course that we'll be developing in the future. In this course, we will, however, see something similar to debugging when we do the dynamic analysis part. Okay, that is pretty much it. To summarize, we just went through the process of a malware author developing a simple shopping list app and hiding some malicious code in the background that steals SMSs when they are received and steals contacts periodically. In the next part of the course, we'll assume that we have no knowledge of what just happened here, and we'll try to gain this knowledge through reverse engineering. We have just created our own Android application. Together, we went through the process that a normal app developer or even a malware author goes through when developing their app. Now we have a malicious app in hand that steals SMSs and contacts in the background. In the next part of the course, we will be analyzing this app. After developing a basic app, which was in fact a malicious app, We will now change our hat and go through the analysis of the malicious app through the eyes of a reverse engineer. Here we will use the tools that we installed during the lab setup section to analyze the malicious app. Using the tools we installed earlier, we will conduct static analysis, dynamic analysis, and automated analysis of our sample. We will start off by providing a comparison of static, dynamic, and automated analysis. We will conduct static analysis using APKTool, Bytecode Viewer, and AndroGuard. Dynamic analysis will be conducted using Objection. And finally, we will show you a number of online malware sandboxes that can be used for automated analysis. Static analysis relies on features extracted without executing code, while dynamic analysis extracts features based on execution. In general, static analysis is more efficient, while dynamic analysis can be more informative, particularly in cases where the code is obfuscated. On the other hand, automated analysis usually involves running the malware sample inside a malware sandbox, while running a number of scripts that perform a combination of static and dynamic analysis. Okay, so we saw how to develop an app if you followed the part of how to develop an app. But whether or not you followed the previous part, we're going to start off with the following scenario. We have a suspicious app installed on our device, which is the one we developed in the previous section. So you suspect this application is malicious and you want to start reverse engineering it and understand what it's doing by having a look at the underlying code. How can we do this? Firstly, we're going to use an important tool that we introduced previously, ADB, or Android Debug Bridge. So Android Debug Bridge, as it is named, is a bridge between the host machine we're going to be doing analysis on and the Android device or emulator. ADB is the tool that you will use to connect your Windows or Linux machine over to the Android device. The location of your SDK folder is usually user folder /appdata/local/android/SDK on Windows, and home folder /android/SDK on Linux. Now in the SDK directory, you will find a directory called platform-tools. And within the platform tools directory is where you will find your ADB tool. This is a very important tool. There are quite a few commands you can run with ADB. Here we'll just show you some of the main ones. So for example, one command is ADB devices. In this case, you will see one device, and that is the emulator. So at this point in time, there's one emulator that we can connect to. If you had more devices, you would be able to specify which device you want to work with by using the -s parameter followed by the device name. Another thing we can do with ADB is pull and push files. What does this mean? Push means that we can send a file to the device, and pull means we can retrieve a file from the device. So in the case of push, try something like this. Push local path, dest path. So let's create a local file here called myfile.txt. Let's push this file to the device by typing adb push, the path to myfile.txt, and the destination path, say /sdcard/. And that will push the file from your host machine onto the Android device. Similarly, if you pull, you can run pull and the path of the file you want to download, and this will pull the file onto your analysis machine. We will actually be using this to download the target app. Okay, another important command is adb install. So if you have an APK file on your host machine and you want to push it and install it on your device or emulator, You can either push it onto the device and then go onto the device and install it, or you can just run ADB install and it will be installed directly onto the Android device. Similarly, you can do uninstall. By running ADB uninstall and the package name, you can easily uninstall the app. But you might be asking, how do we get the package name of an application? We will see how we can obtain the package name in the next step. Before we do that, let's look at a very important command, ADB shell. So this is used to enter the shell of your Android device. Here you can see the standard Linux environment where we are in the shell of our Android device. Now here we can run several commands using system utilities. So for example, pm list package. And this will give us the package names of the applications that are on the device. And so these packages are currently installed. Now, given that we're running in a Linux environment, we can even run utilities like grep in order to help us filter through the results. So say we know that the app has FlipCortex in its name, we can run pm list package pipe grep FlipCortex. And here we can see the filtered results. So in the case that we want to remove FlipCortex, we would just exit the shell. Run ADB uninstall and our package name. Press enter and it will uninstall. But right now we don't want to do that. Let's go back to ADB shell. So the location of the APK files we would want to look at are in the data/app folder. But we don't have permission because the device is not rooted. Here you will see a few different approaches on how to obtain an APK from the device, but we're going to opt for the lazy way. We're going to use an app called APK Extractor. There are different tools. Just search in the Play Store for the text APK Extractor and you will see many results. Find your favorite one and install it. Just search in the Play Store or an online store. Here we are just Googling APK Extractor APK, and it redirects us to APK Pure downloads. From here, we just download the file and drag and drop the APK onto our emulator. This is a quick way of installing it. This is a tool that just goes through your apps and allows you to extract and save their APK. Here you can see it's been installed. Click Open. So you have the list of all your applications. Let's search for our app. It will ask you for permission to access the files and media. Grant the permission. So let's have a look at the shell again using ADB. We're going to go to the path where the APK was extracted. So storage/emulated/0/extracted APKs. List the files. We see that there's hello world, flipcortex.helloworld.apk. Okay. So what we're going to do now is we're going to exit the shell and I'm going to use ADB pull. So if we exit the shell and run ADB pull, storage/emulated/0/extracted APKs/hello world_com.flipcortex.helloworld.apk. You can see over here, one file is pulled and we're given the size of the file. So now we have our APK in our local directory. So to recap, we have a suspicion that there is a potentially malicious app on our device. We used the ADB together with the help of an APK extractor to obtain the APK file. And in the next lesson, we want to analyze this potentially malicious file. Okay, so we're now in a situation where we have the suspicious APK available. First, let's rename the file. Let's call this flipcortex.apk. Okay, now we just have this file named flipcortex.apk. Actually, let's also move this file. Let's go to Home, and let's create a folder called flipcortex. Let's move our APK to the newly created folder. So all we did so far was just rename files and move them around. We've not started the analysis yet. So now we're in a folder called flipcortex. Now, if you remember before, we installed APK tool. APK tool is an extremely popular tool that is used as a basis for many analysis tools. Let's run the command apk tool d flipcortex.apk. So basically, this just starts decoding our APK. And you'll see that this creates a new folder called flipcortex. And so by running apk tool d on the APK, APK tool creates a folder with the app's Smalley code inside. Let's go to flipcortex and see what we find. Here we see the Android manifest, which we had seen when we were developing the basic Android application. Let's have a look. Nano Android manifest.xml. We can already see a lot of information about this application. We know that there's a service in the app with a receiver, a content provider, and 2 activities. Now remember, in this case, we saw the development of the app, but this is not usually the case. Usually we obtain an APK and we have no idea about the code behind it. So this is already a lot of information that a normal user would not have knowledge of. So here there's a suspicious APK. We don't have its source code, but we're able to start obtaining information like the Android manifest file, which is an extremely useful file to understand what the application is doing. From here, we can also see that the application uses permissions: internet, read contacts, and receive SMS. So technically here, we can already start confirming some of our suspicions. This app is a shopping list app, but it seems to be requesting SMS permission. That doesn't really add up. This isn't enough evidence though. Who knows? Maybe the app uses SMS for some sort of 2-factor authentication. So let's put that suspicion on hold for now. So what else do we have in our decoded folder? If you go to resources folder over here, so say, for example, layouts folder here, CD layouts, you have the layouts, which are the user interface of the app. We can see activity main.xml, which is the main layout associated with the main activity. You can see the layout information inside. So again, always keep in mind that this is from an APK, not from the source code. So the fact that we can just get this from an app installed on your device is quite impressive. Now let's go back to the manifest. So let's have a look at the default activity here. We see the default activity here is in the default main activity, which is com.flipcortex.helloworld.mainActivity. So usually the manifest is a good location to get the starting point of an app. Now let's go back to the folder and we can go to the Smalley directory. And from here we follow the path that we just saw in our manifest. cd com/flipcortex/helloworld. Here you should find mainActivity.smalley, which is the default activity of the suspicious application. Okay, so here we're going to be presented with the Smalley code. Now, Smalley, it's not Java. Smalley is human readable bytecode. You don't need to fully understand Smalley, but it will help to understand more or less what the app does. In the following lessons, we'll see how you can still understand the code without needing to fully understand Smalley. But again, by using only APKTool, we already got a lot of information, including the Smalley, which would be able to tell us what the app does step by step. Okay, so let's work out a small challenge. Say our network security team tells us that they're noticing a lot of data being sent to this URL, postman-echo.com. And you're tasked with investigating this app to know if it's the source. Now, how can we try to determine if there's any code that we can identify related to this postman-echo.com? So if you are on a Linux machine, you can run the grep command. So running grep-r postman-echo. There you go. So we already found something here. So for example, we can go into this code, search for Postman, and here you see that, in fact, there is a string with the URL we were warned about. So there you go. Here you would be able to almost confirm that yes, this app is responsible for the data being sent to postman-echo.com. So in the previous lesson, we saw that by using APKTool, we were able to obtain Smalley code of an application in which we did not have the actual source code. In an ideal situation, you would get the actual source code, but that is not possible. However, there are tools called decompilers that are able to provide almost Java source code. There are a number of different decompilers available. Popular ones include JDGUI and JAD. However, there is one tool that contains a different number of decompilers. This tool is called Bytecode Viewer. So we downloaded this in the previous section. Let's go to our downloads folder. Now we run it using java-jar bytecodeviewer.jar. This tool is also available on Windows. In that case, you would just click on the jar file. Now let's open the user interface of Bytecode Viewer. What we want to do here is add our APK. So home, flip Cortex, and here we have the APK. So when you import the APK, Bytecode Viewer, which is an excellent tool, is going to decompile the app and provide you with the decompiled source as well as the bytecode and Smalley. You have your packages on the left, and when you click on, say, main activity, you can see that we've got what looks like Java code. Now, it is important to note that this is not compilable code. Usually there will be errors because the decompilation doesn't work perfectly. But from here, you can see a more human readable picture when compared to Smalley. Now, Bytecode Viewer has different panes. The first pane is the Java decompiler, which is decompiled using Fernflower. And here under the second pane, you can see the actual bytecode. But we can change these. So for example, what if we don't want to use Fernflower, but instead we want to use JADX? Change the pane, close it and open it again. And here you see that the same code decompiled using JADX. So sometimes you find that certain decompilers work while others give you errors. That is why a tool like Bytecode Viewer is great. Another thing you can do is set a pane to show Smalley. So again, go to the pane and choose Smalley code. Let's close this again. And again, here you can see we now have JADX decompiled code on the left and the Smalley code on the right. The Smalley is the same code as we saw before using APKTool. So this is very good for seeing a side-by-side comparison. For example, here we have request permission method in Java, and here we have it in Smalley. So all of this method over here, which is request permission, translates to this code over here in Smalley. So Java is more human readable, but Smalley is more reliable. The Smalley code is compilable, meaning you can technically change some values in the Smalley and recompile it. This is not the case with the decompiled Java. So this takes some getting used to. At least if you have a preference of seeing Java and maybe you hate Smalley, you can use this view to follow the Smalley code, but understand what it is doing in its corresponding Java code. Okay, so let's consider the challenge we presented earlier, where the network security analyst told us that they saw data being exfiltrated to Postman-Echo. Now, Bytecode Viewer has a search utility over here. We can search strings, regex, method calls, and field calls. So based on this suspicion that the network security analyst told us, let's search Postman. And yes, here we can see that there are 2 instances of Postman-Echo, and we can see 1 instance inside SMS receiver. Let's dig a little deeper into SMS receiver and try to figure out what's happening over here. So, okay, here we have a broadcast receiver. In a broadcast receiver, we're going to tap on the on receive. Now in on receive, he's checking the SMS that we received. Okay, they're creating the SMS, defining a string called SB2. So SB2 is the SMS that we just received, and here we can see that they are starting a new network task and passing the SMS as an input to the network task. We don't have the task over here, but we have it as SMS receiver $net task. So net task is pointing to access 000, but we do not have decompiled code of access 000. So this is a good example for us. Here we have a case where we can try different decompilers to make better sense out of the code. So maybe JADX wasn't good enough to give us information. What we could do in that case is change the decompiler. Let's choose, for example, Fernflower, which was the default one. Okay, close and open again. Now, if we go to net task, we can see it accessing access 000. Then if we go back to SMS receiver, we can see what access 000 is doing. So what it is doing here is calling HTTP post and passing in the SMS data as a parameter. Then if we look in HTTP post, we can see the Postman-Echo URL. So here we have some suspicious activity where we have an app that is meant to be just a shopping list, and for some reason it created a broadcast receiver to receive SMS, and it sent the SMS to a server. So just like that, by using the decompilers, we've managed to go through the flow of the code, and we understood that this malware is actually doing something quite malicious. Also, it was a good example to show the need for different decompilers. Some are better than others, and sometimes it is best to use them in combination. The most trustworthy source, however, is always Smalley, since it is compilable. However, as we saw here, it is less human readable. So far we've seen how you can use APK tool to obtain Smalley code. Also, how to use a tool like Bytecode Viewer or directly use a Java decompiler to be able to obtain the almost Java code. The thing is that as an analyst, at least initially, you are usually looking for the same things. Like, okay, what permission does this application have? What are the services that are listed in the application? To answer these questions, you could either do what we showed in the previous part, or you could develop your own scripts on top of the outputs of tools like APK tool. AndroGuard is a popular example of a tool that uses scripts against these outputs to produce its results. So we showed how to install AndroGuard earlier. To use AndroGuard, just type AndroGuard. See the options here. Okay, so when you run AndroGuard analyze flipcortex.apk. We are now in a situation where AndroGuard was run against flipcortex.apk, and we can run a bunch of commands on this APK. So to run commands on the APK, you do a dot. So say, for example, you want to get the requested permissions. This will show what permission this APK is using. There are other things that could be of interest. So for example, you want to see what are the services of APK. a.get_services. Same thing for receivers. a.get_receivers, and so on. More than the actual tool, here we are saying that as an analyst, once you get used to your process, it would make sense to develop scripts on top of outputs to automate the process. AndroGuard is nothing more than a collection of Python scripts on top of the APK outputs. So for example, if you want a script to find all the permissions being used, you run apktool against it, do some string analysis on the XML, and find all the permissions inside, which is essentially what AndroGuard is doing over here. So now we're going to use objection for dynamic analysis. Before we go into this, there's one thing we need to mention. Earlier on, we saw how to extract an APK from our phone, but the APK we were working with was actually a development app. This means that the app was not signed. On the other hand, when you download an APK from an app store, you'll find that the developer signed the app. When the app is not signed, you may encounter a few problems, particularly with dynamic analysis. So let's go through the signing process. What you're going to do is go to Android Studio, and you're going to click on Build. Here you're going to have an option to say Generate Signed Bundle /APK. Okay, so click here, follow the wizard. You're going to click Next. If this is your first time signing an app, you're probably not going to have a key store. So in that case, just create a key store here where you fill in password and you confirm password. Give it the name and the password validity. By default, it is 25 years. If you want to increase it because of what happened with the Millennium bug, go ahead and increase it. Then you can give information about the certificate. Here we'll just use one created earlier. When you click Next, make sure version 1 and version 2 are both clicked. Choose Debug or Release, depending on whether you're going to release or not. Okay, let's do Release. Choose the path. And just like this, you'll be able to see. Let's open the file where this is located. Go to the path you specified when signing. In our case, it's this. And here you have the signed APK. So the APK release is your signed version of the application we were working with. Now this should work with our online sandboxes or dynamic analysis tools. That's your signed APK. We sign it because we're going to install it to the emulator. So what we're going to do is start the emulator. And in this case, we actually use an emulator, which is version 24. This lab machine is a bit slow, and sometimes newer emulators tend to have higher requirements. In your environment, you can run your preferred version. If need be, just go to the emulator or AVD part of the course earlier on, in case you need to revise how to set up an emulator. Okay, so before we continue, let's recall the part of the static analysis. If you remember, in download, we had the bytecode viewer. depending where you saved your bytecode viewer. Let's run that again and have a look at the code. Through some analysis, we can try to identify some points of interest. So just find your APK. So it's under release, and you just drag it onto the window just like that. So if you remember, the app was receiving an SMS and exfiltrating it. So it was stealing the SMS and sending it to some URL. Now we kind of managed to understand what was happening, but maybe we want to confirm even further. Also, in certain cases, the statically decompiled code may not have been so clear. And maybe you're unable to see in code what is happening exactly at some specific methods. That's where dynamic analysis is extremely handy. Consider this case here. Remember we had an HTTP post, but assume we couldn't trace exactly what was being exfiltrated. Maybe we suspect it's the SMSs, but we're not sure. Through dynamic analysis, we can try to understand what is happening over here at particular points within the class during execution. Okay, so let's have a look at objection now. We're going to go where the signed APK is, and we want to run objection patch APK, source and the path to our signed APK. Actually, let's move the APK from the Android Studio path to the FlipCortex directory we created earlier. Okay, so we moved the APK. So now run objection patch APK, source and the path to our signed APK. And we can pass the gadget version. I had some issues with some versions and this one worked, so just to be safe, let's use this. Now this is going to instrument the APK, meaning it's going to decompile the app, inject code, and recompile, and sign the app. All of this is done automatically while also using another tool called Frida for instrumentation. This will allow us to hook into specific functions of the app dynamically. Okay, so we give it some time, and we can see it is signing the new APK. And if we look into our folder now, we can see the instrumented version of our APK over here. It appended objection to the name. Okay, now we can go ahead and install. If you remember, we can use ADB install. So ADB install and the name of the APK to install. Now we can see that we can run the app, but nothing will happen. This is because it's waiting for us to run objection against the app. So objection, explore, then it will run the app. Now we want to hook onto the HTTP post. To do this, we're going to run Android hooking, watch class method, pass the name of the method, including the entire package and class before. So com.flipcortex.helloworld.smsreceiver.http post. Then we're going to dump the arguments using dump-args, dump backtrace using dump-backtrace, and finally dump the return values using dump-return. Great. So now we're going to run this by pressing enter. Now what this does is it hooks onto the instance of the HTTP post method, and if it sees that this method is invoked, then it dumps all the info we specified in the console. So if you remember, when we developed the app, we were able to do debugging inside Android Studio by adding breakpoints. Here we sort of have a similar behavior where we can hook onto specific points in the code and obtain info about the variables at runtime. So this is quite useful. Okay, let's open the emulator here, go to send an SMS, and let's see what happens when we receive an SMS. So click on phone, change the text, write something like, "Hey receiver," then we click on send. In the console, we can see all the dumps. This tells us that HTTP post was invoked as soon as the SMS was received, which is what we expected. Now, also, if we look at the arguments, we can confirm that it actually was the SMS that was passed as an argument. Similarly, if we look at the return value, we can see the URL with the HTTP parameters that are being exfiltrated. So we can see postman-echo, and we can see the contents of our SMS. So here we are 100% sure that the SMS is being stolen. Through static analysis, we got a clear picture, but it's not always so black and white. Here we have 100% confirmation that as soon as we receive an SMS, that SMS is being sent over HTTP post to postman-echo. So we can go to our network analysts and say, yes, your assumption was correct. We're seeing data being exfiltrated to this server, and the data being sent is SMSs. So far we've seen static and dynamic analysis. What we're going to show you next is a malware sandbox. More specifically, an online malware sandbox. There are a few malware sandboxes available online. Here we'll just show you a few. So there is this platform called kudos.com. This is quite research oriented, and it has this interesting malware analysis collaboration concept. It is still in beta version and has been for a while, but it's still useful, especially as a resource for malware samples. There is another tool called apklab.io that is actually made by Avast. It is quite a new tool, and it's probably not in beta anymore. I believe they have a registration process, but we were able to obtain an account easily enough. So you just need to send an email with a registration request. Then there are other public sandboxes, for example, Ammas, not sure how to pronounce that, and Sandroid. So with all of these tools, you can get an APK. You upload it, and it automatically performs static and dynamic analysis for you and produces a report. The report will show you what potentially malicious behavior was identified through static and dynamic analysis. So these are publicly available and they're online. In the near future, in a more advanced course, we'll go into more detail about more advanced analysis techniques, but also more importantly, we'll go through the steps of setting up your own automated malware analysis sandbox. So you can locally set up and host your own local instance of a tool similar to these. There are many advantages to this. A main one is that you can also do a semi-automated analysis where you would be able to execute an APK but also interact with it while observing the behavior within this analysis. Even though there is an automated analysis available, everything we've done so far in terms of static and dynamic analysis is very important because at the end of the day, you need to understand what is going on in the background. And a fully automated approach is never a silver bullet. Sometimes you have to dissect an app in order to really understand what it is doing. Okay, let's try to upload the APK to apklab and Kudos. Set up your own accounts. Let's start off with Kudos. Then upload the APK, like so. We're going to do the same thing to apklab.io. Actually, here we can drop it. And it is uploaded. Actually, let's do the same thing in Ammas. Log in using their account. Upload the signed APK. Choose the file and click on Static and Dynamic Analysis here. You can choose Monkey or UI automation. These are two different techniques. They're just different tools that are used during the dynamic analysis to recreate the user interaction with the app. This is used to expose as much behavior as possible. Imagine a scenario where most of the malicious activity is based on the user clicking on a specific button. If the click is not automated, then the malicious activity would not be exposed. If the analysis environment simply opens the app but doesn't click on any user interface elements, then there's a possibility that code doesn't get triggered, and if the code doesn't get triggered, then the indicators will not be exposed during the dynamic analysis. Okay, so same thing on Sandroid. Just click Upload here, select File, Upload. So these are 4 different public sandboxes. We can use different ones and compare the reports. Eventually, just choose whichever one you prefer. Let's give them some time because since they're running the dynamic analysis in the background, we have to give them time to analyze, and we'll get back to the results later. So the first sandbox analysis to finish was the one at apklab.io. Here you can see the results. Let's have a look at the general dashboard over here. Okay, so basic stuff. It tells you there are 2 activities, 1 server and 1 receiver. It shows what permissions are being used, shows you what URL the malware is connecting to. Usually this is the kind of stuff you would want to try to identify by going through code. So this is a really good start. As an analyst, this is an ideal scenario. You upload malware, let it run, and see the results. Then besides the general dashboard, you have more detailed results. For example, static analysis. Actually, before we see this, let's have a look at Kudos. In Kudos, you can search for APKs, including the one you just uploaded. So here we have the hash of the APK, and we can just search using this. So you might see that no analysis was done for a specific APK. In that case, just click Analyze or Reanalyze if you want a new analysis, like so. And an analysis request has been sent. Report generation can take several minutes, but it will give you a notification when it finishes. So you'll probably get an email report saying, okay, your analysis is complete. I'll just show you the results in one of the sandboxes, which I think is one of the best ones actually, apklab.io. But whatever you see in apklab, you'll probably see similar results in the other sandboxes. At the end of the day, in the background, all of them are doing similar tasks and using similar tools. However, apklab seems to be quite a serious and advanced tool. Technically, in the background, they're using the tools we showed you earlier while providing the user with a UI. I believe apklab goes a step further and they apply some advanced analysis, maybe using some AI. Oh, and the other thing about the sandboxes, as I mentioned earlier, they're also good sources for actual malware. So if you want to analyze a specific malware, you can go to an online sandbox, search by name, package, MD5, etc., and find your sample. Since these are public repositories, they're receiving malware samples from all over the world. So for example, if you want to find a stage fright sample, just come here and search stage fright, or do some research and find the hashes for stage fright and search here. Or you can use tags. For example, you're researching fake installers, so search tag : fake-installer, and you'll find several samples. So let's have a look at the analysis reports that apklab generated. Under the static analysis, it gives you some basic information about the application's suspicious permissions. It tells you that it goes through SMSs on receipt, creates SMS data, again related to SMS, queried contacts. So again, here it is telling you to be careful. It's reading your contacts over here. This was all done automatically. Okay, what else? URL strings. This is quite interesting too. Okay, so from the static automated analysis, we just saw that it reads SMSs, it reads contacts, and it sends data to Postman-Echo. This is all information that we saw in the Building a Basic Android App section. But remember, usually as analysts, we are not aware of what the developer did, so we are working blindly, and all of this info is valuable. Okay, now let's look at dynamic. So it says that they ran it on Android 6. Here we have network stats, showing where data is being exfiltrated to. So it's interesting to see if data is coming from or going to a specific country. Network dump. So we can download it and see more info on the traffic data. Permissions. Again, here it sees what permissions were requested, but more importantly, which ones were used. Entry points. This provides info about the components together with screenshots. Okay, this is a lot of information that we got from an automated analysis. For the analyst, this is great. You upload the app and you have all this info about the app's behavior. Now, while it doesn't provide a full picture, it does give you good insight on where you should go to look deeper. So for example, this here tells you that there is a receiver. If you want to look deeper, you can do some static analysis manually on top of it. We can use Bytecode Viewer or other tools we saw earlier and dig deeper. So here we saw an automated online malware sandbox. In an upcoming course that we're preparing, we'll show you how to set up your own malware sandbox. So you could develop your own Android malware sandbox, but in your own local environment. There are definitely some advantages to this. If you're testing an application that is targeted at your organization, maybe you don't want to upload it to a public repository, so you could obtain the same results, but in your contained environment instead. There are also some other advantages. So for example, here you have no control over the interaction with the sandbox. Whereas if you set up your own environment, you can interact with the malware as the analysis is being conducted. So you can click buttons, log into websites or apps, run several apps, and so on. This is not always possible with online sandboxes since we have no control over the emulator or devices running the analysis. Another advantage is that you can set up a proxy to intercept HTTPS traffic, which is extremely useful for network analysis. You can also perform instrumentation to bypass certificate pinning to ensure that you are in fact able to intercept HTTPS. All of this is more advanced and doesn't really belong in an introductory course like this. But if you liked this course, then you'll definitely find our more advanced one extremely interesting. We just saw the analysis of the malware sample that we created earlier on. We conducted static analysis using APKTool, Bytecode Viewer, and AndroGuard. We used objection to perform dynamic analysis in order to analyze the app behavior during runtime. And finally, we saw a number of online malware sandboxes that can be used for automated analysis and the kind of reports that they produce. In this section, we will take the techniques that we learned during the analysis section and apply them to a real-life ransomware case. The malware we will be looking at is SimpLocker. This is a standard ransomware sample that prompts the victim with a warning screen telling them to pay a ransom to restore the device. In the background, SimpLocker encrypts the files on the device storage. By reverse engineering the malware sample, we hope to obtain a good understanding of how the files are being encrypted. This will allow us to create a decryption tool that decrypts the encrypted files. The goal here is to use the knowledge gained in the previous sections and apply them to a real-life use case. We will start off by showing a report generated during the automated analysis of the malware sample. Then we will run the malware sample on our emulator in order to observe the behavior. Next, we will apply static analysis techniques to the sample in order to obtain the necessary information that could lead to decryption. And finally, we will create a decryption tool that will restore the encrypted files on our device. So far, we have seen how to develop an Android app and how to analyze a potentially malicious Android app. In this case, we're going to look at an actual malware sample called SimpleLocker or SimpLocker. So SimpLocker is ransomware. It is a bit old, but it is a very good sample to use in a training course. I say this because within the analysis, we'll be able to extract very useful information that can be used to decrypt the files that were encrypted by the ransomware. So what we will do is analyze the ransomware, determine how it encrypts our files, and develop a tool that is able to restore our data by decrypting the files. In other words, we're going to create a SimpLocker decryption tool. SimpLocker is an interesting sample because we have all the information needed for decryption within the source code. Okay, so Kudos is the online sandbox I mentioned earlier. It's useful for doing automated malware analysis, but more importantly, it's a useful resource for APKs. Once you sign up, you'd be able to search for APKs by using search fields like malware family name and find the APK. You can search by hash, app name, developer, package name, tag, and so on. Tag is quite a useful search functionality. Kudos has a large research community, and if someone would have tagged SimpleLocker as SimpLocker, then you should find all the associated samples through the tag. So here you can see that someone tagged this specific malware, or rather this specific APK, as SimpLocker. And they also tagged it as ransomware. If we search the tag ransomware, we'd probably find a whole bunch of other ransomware samples. This would be useful if you're doing research on ransomware samples. And here, detected means that it was detected as malware. So let's click on this SimpLocker sample. Here we see that it has an analysis section, and here's where the analysis part comes in. So this is where you can see the hashes and basic APK data. Here is an automated result of AndroGuard. We saw AndroGuard and the possible results it can produce earlier on. So for example, here it shows there's a main activity. Here there are 2 receivers, a few URLs. This here is quite interesting. We can see that it uses Tor over here. There are 2 services. The Tor service, again indicating that it probably uses Tor. Okay, what else? A few filters, permissions. Here we can see that it writes to external storage, so that's quite interesting for us. What else? It says that it uses crypto. This is probably used to encrypt the files. Network. Okay, there are some network communications. We can resolve these and try to identify the URLs if necessary. DroidBox. This is a malware dynamic analysis tool. The thing is, it's a bit of an old tool, so that's one of the reasons why we didn't show you DroidBox. Here it seems they ran it against DroidBox. We can see that there are a few file writes, file reads, service started, DEX calls. So there is dynamic code loading. So yes, there's a lot of information we can obtain from here from an automated analysis report. However, we won't just be relying on this information. We'll be going deeper using the analysis tools that we demonstrated earlier on. First, we'll run the malware in our emulator and we'll see what the impact is. So here we'll confirm that it's actually encrypting our files. Then we'll analyze the sample and hopefully we'll be able to extract the code or the information that would help us to decrypt the files that are being encrypted. Finally, we'll try to decrypt the files on the emulator to show that our decryptor tool worked. Okay, so let's try and run this malware on an emulator, and let's try to understand what's happening during execution. Before we do this though, I have to make a disclaimer. It's not really recommended to be executing malware. You definitely don't want to download this APK and run it on your actual device. Definitely do not do that. Here we are running in a contained environment. We're running on an emulator on a PC that's dedicated for this specific work. We are also going to disable the network connectivity. In other cases, you may want to configure a proxy and take other measures, but here we are outright disabling the network connectivity. If you're not confident in what you're doing, don't execute the malware. Just follow the video and don't stay experimenting. The last thing you want to do is download this APK on your phone and install it. Definitely do not do that. Okay, back to Kudos. Kudos has this cool functionality where you can download the APK samples. So here we just downloaded this simple locker sample. But before we do anything else, let's create an emulator. So we're going to create an emulator that's an old Android version. The reason being that this malware is old, so just in case it didn't handle any permissions or anything like that, let's just be safe and run it on an old emulator. We already have a version 16 emulator configured, so let's work with that. Let's call this SimpLocker and configure hardware acceleration. Remember, if you're running in a VM, you probably want to use software acceleration. Default settings should be good. When you are done, click Finish. Okay, so we've created the emulator and next we need to run it, but we're not going to run it from here. We're going to have to look at another way of running the emulator. So let's go ahead and close Android Studio. Go to the SDK folder. So in our case, it's Android-SDK. Here you'll find a folder called Emulator, and if you go within Emulator, you'll see that there's a tool called Emulator. You can use that to launch your emulator. To do that, you just do emulator-avd and the name of the emulator you just created. SimpLocker. Okay. And this will launch the emulator using the emulator tool rather than opening Android Studio every time and opening the AVD manager. So here we see that the new emulator is launched. Let's go ahead and add the SD card. So you have to go to API Demos, Content, Storage, External Storage, and click Create. So let's go back to our terminal and run ADB shell. If you go to SD card, go to Pictures, we will see that we have a demo picture over there. So what we can do here is ADB pull. So go to SD card / pictures, and you will see demo picture.jpg. So let's pull this. ADB pull, if you remember, is used to bring a file from the emulator to your device. Type ADB pull and the path. Now if we go on downloads, we see that we have a demo picture that is provided by Android over here. What we want to see now is whether SimpLocker encrypts this demo picture. Let's go ahead and remove this demo picture from our downloads folder. Okay, now before we connect, we're going to turn off the internet connection, just in case. Okay, and now we can run ADB install. The file starts with 8, and install the APK that we just downloaded from Kudos. Let's have a look. And we can see that it's been installed. Now the user has this malicious application, and once he clicks on it, he's prompted this notification which seems to be Ukrainian. It is saying something along the lines of, okay, we have your data, you've been going on sites that you shouldn't have been going on, you need to pay this amount to so-and-so. And as you can see, you can try to minimize it, but it will keep prompting you with the message. So this is the ransomware. We installed the malware and we're stuck with it. Now let's remove the malware using ADB. ADB uninstall org.simplocker. Okay, so it's uninstalled. Now the problem is, if we have to run ADB shell again and go to SD card/pictures, we can see that the malware has encrypted our file. So by simply uninstalling SimpLocker, we didn't get rid of the problem. We have a situation where all the files on our device have been locked and encrypted. So let's confirm that the files are encrypted. Again, using ADB pull, let's do ADB pull to obtain the encrypted file. And we can see over here, this is our encrypted file. So that is it for now. Next, we'll see how we can get useful information through static analysis of this sample. The goal is to gather enough information that will allow us to decrypt the encrypted files. So now we have our SimpLocker malware. We saw the results after running on a public sandbox, but what we want to do is analyze the APK and see if we can obtain any useful information from this APK. And ideally, this information can be used to decrypt our files that are encrypted on our emulator. At this point on your emulator, you should have the encrypted files. First, if you remember, we had a tool called JDGUI. We had placed this in downloads. But before we run JDGUI, let's run njarfy, which is a tool that we need to run against the APK to be able to upload the jar file to JDGUI. So to do that, we go to user, local, njarfy, and here we have the script, njarfy.sh, and we're going to run it against the SimpLocker APK. So this might take some time. It seems like there are quite a few classes in this app. So here we're converting the APK into a jar file, so then we can import the jar file into JDGUI. In the meantime, let's run JDGUI. So java -jar JDGUI. There we go. And over here, once we see that njarfy file is complete, we just need to import the jar file that was generated. So if we had to go back into our folder here, we'll see that it generated a file. Okay, now we'll just import this jar, and there you have it. You have your source code, just like with bytecode viewer. Actually, bytecode viewer uses JDGUI as a Java decompiler in the background, among other decompilers. So one thing you may notice here is that we are running in JDGUI and not in bytecode viewer. This is because there is an issue with this specific APK. So if you try to run this APK in bytecode viewer, or actually you try to run APK tool on this APK, you will receive errors. This happens occasionally with APK tool, i.e. receiving errors when running APK tool. Usually it just requires an upgrade of the APK tool version because it would have some bug or some unsupported code. In some cases, like in this case, I suspect it has to do with the special characters, so it could be that they have some Ukrainian or Russian or Chinese characters in the application. Because of this, APK tool, which uses Java in the background, is causing the app to crash. There are ways to fix this. It's usually on a case-by-case basis. To be honest, it's not really worth investigating for this specific case because it's a bit out of scope. What we want over here is to obtain Java source code, which we can try with JDGUI, and in this case it works. Okay, so that's just a side note. So here you see that there are different packages, but if you remember in the automated analysis, we saw that there's a package called org.simplelocker, which is where we have a lot of the main code. So for example, here there is the main class, which launches the main service. And then you can follow the main service and you can see that, for example, here they are starting a Tor connection, or they're checking if there is a Tor connection and then starting it. We're not going to go through all of the code, but this is where you could get some useful information if you had the time to go through it. So for example, when you see that it opens a Tor connection, you might assume that maybe it's connecting to a command and control server. Then using dynamic analysis, say through objection, we could hook onto specific calls we identify here and see if any data is being sent from the server to our application. But we're not going to go through this right now. We're just trying to look at the code and trying to see if there's anything useful over here for decryption. So let's have a look. Here's quite an interesting class actually. This class is called Constants. And as you can see in Constants, you have some interesting data listed very clearly. For example, here you have the admin URL, so it shows what is probably the command and control server. They left it statically defined and in clear. Here we are quite lucky, but this is not always the case. This is actual malware that was locking people's devices, so this kind of information is actually found in malware. But here's the most important thing we have, the cipher password, which is extremely useful. If we know what it's encrypting with, hopefully we can decrypt using the same cipher keys. Okay, and here's something interesting as well. We can see what file types are being encrypted. Extensions to encrypt. So these are the extensions that are being encrypted. And in our example picture, we saw that it actually was encrypting the JPEG and renaming it as jpeg.enc. So that kind of matches with what we saw when we ran it on our device. Okay, let's see. Over here, there's a file called AEScrypt. Here we can see that they have a function called decrypt. And there we go. We don't even have to do the work. We don't even have to try to understand what the encryption part is doing and try to reverse it, because they are actually kind enough to offer us the decrypt function, which in the next step, we'll try to copy and paste this code into Android Studio and see if we can produce our own decryption tool. So this is quite important for us. We saw what the cipher key is. We saw that they are providing a decryption method. So now we can start thinking of maybe creating our own Android app that parses through all the files that have been encrypted and run this decrypt method on top of it, passing the cipher key as a parameter. Here we can see the files to encrypt being used. So, okay, it seems that there is a file encryptor class. They have a method that gets all the file names. Here there is a recursive function where they're parsing through all the files where they want to encrypt. Then they have an encrypt function which goes through all the files to encrypt, runs AEScrypt with the cipher key, and encrypts all the files. So here we can see that our assumption of what the ransomware was doing was correct. And we can see the key being used. So just over here, with a quick analysis of some very clearly named functions and classes, we can see that there is a command and control server. We found what the server is. We see that it receives some commands from the server. We see that there is an encryption class. We see that the encryption class being used is AES. Even better than that, we have the cipher key that is being used. So again, we have a lot of information here. Hopefully, using all this information we obtained from just static analysis, we'll be able to decrypt our demo pictures. And in the case of an actual malware, you'll be able to restore your system by decrypting the files. Okay, so now we have a situation where we know enough about SimpleLocker to be able to do the decryption of our files. So Simple Locker is encrypting our files, and we want to write a simple application that's able to use the code that we obtained through the static analysis and decrypt the files that were encrypted by Simple Locker. Okay, so before we do that, let's check our emulator, just in case we didn't save the state of the emulator for some reason, and the files that were encrypted are not there. So let's just confirm that the file is there by doing adb shell. CD SD card, CD pictures. So we turned off our emulator and we didn't save the state. So in this case, the files are no longer there. No problem. We can quickly go over the steps of installing Simple Locker. We need to disconnect the internet, go to Downloads, ADB, Install. There we go. So it's been installed. Let's just make sure that we have the SD card part in the storage enabled. Okay, create. This will create the demo picture. Now we're going to run Simple Locker, get the notification, maybe give it a few seconds so it encrypts our file, and then we can run adb uninstall org.simplelocker. There we go. Now we go to adb shell, CD SD card, CD pictures. We will see that we have our encrypted file. Okay, so now let's try to develop a simple Android application that will be able to decrypt the encrypted file. And the source for the Android application is going to come from Simple Locker itself using static analysis. So we're going to create a new project. Let's call it, for example, Simple Locker Decryptor. So here we're going to do some revision of building an Android application section. If you didn't follow that part, it's not a problem. We will be building a very simple application, and most of the code actually comes from Simple Locker itself. So the first thing we need to do, we need to open the manifest. And since we're going to be working with the SD card, the first thing we need to do is add permission. So uses permission, Android permission, dot, write external, storage. Okay. And we close the permission. So since we're going to be writing to file, we need to obviously request this permission. Now let's try and obtain the source code from here. We have quite a lot of code that we can just copy all together. Just copy everything from AES-Crypt. And here we're going to add a new class and call it the same .AES-Crypt. There we go. Okay. Now we are about to see a lot of errors over here. Notice that we changed the package name because we need the package to match our project. To save us some time, I'm just going to remove the encrypt function since we are only going to be using the decrypt. And let's just fix the content a bit over here. Let's see, here you're going to have some errors where you can automatically fix and add the exception with its signature. Same thing over here. Remember, Alt and Enter will give you the required fix. Here, JDGUI has a weird way of passing the parameters, so all you need to do is take where you see an error like this. Just take these parameters and pass them directly. It's just the way JDGUI decompiled the passing of the parameters, which is kind of breaking stuff. So the same thing all over. We're going to take the parameter from here, pass it to here, and remove the line. We just need to do the same thing throughout. Keep fixing the errors by clicking on Alt and Enter. and fix all the parameters that were passed incorrectly. And that's pretty much it. We have our AES-Crypt class that has the decrypt function inside it. Okay, now if we go back to Simple Locker static analysis, we see file encryptor is where AES-Crypt was actually being used. So here he has a way of parsing through all the required files. In our test, we're just going to test it on one specific file, the demo picture. But then in reality, all you'd have to do is a method that parses through the entire SD card and find all the files with .enc in the file name. But we don't really need to go through all of this. Let's just copy this small part where AES-Crypt is being used. So in decrypt, all they're doing here is initiating AES-Crypt. Let's actually copy all of this and we'll fix it ourselves. So we're going to copy all decrypt and we're going to paste it directly in the main class over here. So here we have the function called decrypt. Here he's initializing the class, AES-Crypt. Again, we need to fix how the parameter is being passed. Instead of passing it like that, we're going to pass it there. No need to check if storage exists for now. And again, we're not going to go through all the files. We're just going to specify one file. Let's just take the small part that we need. Let's remove everything else. So we're just going to call the class and then call the function decrypt within the class on the file that we're specifying. So the decrypt accepts two parameters. It takes a string as the file input and one as the output. That's where you're going to put the file name that you want to decrypt and the output file where you want it to be decrypted to. So let's just do string to decrypt equals SD card / picture / demo picture.jpeg.enc. So that's what we want to encrypt. And what we want to decrypt, let's call it dest decrypt. So destination decrypt. So that's where we want to place our new file. So that's the first parameter we're going to pass through the decrypt. The second parameter, we're going to pass destination decrypt. Here, we're not going to actually delete the file, but what they're doing is they're actually deleting the old file. We're not going to delete it just in case it doesn't work. So if anything, we test it out with one image, and if it works, we'll start deleting the files. But we don't really want to delete just in case the decryption doesn't work and we end up encrypting the file even more and make it unrecoverable. Okay, so let's create a method, public void unclick. So we're going to do an event handler here. So if you remember, to create an event handler, you have to set it as a view. And then over here, let's just call the decrypt, which is decrypting one specific file. Okay, let's just add the exceptions. So now in our user interface, we're going to drop a button. There we go. No need to fix the position. But we do need to just add the event listener. Over here on click, we're going to tell it to call the method onClick. That should be it. Let's have a look. Okay, so let's try to run the decryptor. Just click Run App or the play button, depending on whether you ran it before. This will install the app on the emulator. But before, let's confirm that the file is still encrypted. So cd SD card / pictures, list files, and yes, we can see that it is encrypted. Now let's click on the button in our app. List the files again, and we can see that it generated a decrypted file. Let's just confirm that it is decrypted. run adb pull /SD card /pictures /demo picture.jpg. So we downloaded it. We actually ran ADB from our home folder flip. So let's go to flip. And there is our demo picture. You can see the hot air balloons, so the picture has been decrypted. Okay, so your next job would be to parse all the files in the SD card that end in .enc and run the decrypt function on them. So there you go, you have your decryptor. In this section, we saw a real-life use case of malware and the benefits of applying reverse engineering. Through the artifacts discovered during analysis, we were able to obtain the decryption code that would allow us to create a decryption tool for our encrypted files. This completes our course. We hope that you enjoyed going through the lessons as much as we enjoyed preparing them. As mentioned earlier, we are currently working on a follow-up course that is a bit more advanced. In this course, we will dig deeper into certain aspects of reverse engineering while also providing you with the tools to set up your own malware sandbox.